Gentlemen, in the last class we discussed the different properties of similar figures. What are the different properties of similar figures? In similar figures, figures with the same shape but a different size are called similar figures. In similar figures, the corresponding angles are equal and the corresponding sides are proportional. But in congruent figures, corresponding sides are equal as well as the corresponding angles are also equal. Now we are going to discuss similarity of triangles. Similarity among the triangles. When do we say that the two triangles are similar? If their corresponding angles are equal and their corresponding sides are proportional or in the same ratio. Based on these facts of similarity of triangles, we can prove an important theorem which is called basic proportionality theorem or Thales theorem. Thales theorem. This theorem is named after the famous mathematician Thales. Thales theorem or the basic proportionality theorem, in short BPT. This is an important theorem, theorem 6.1. You have to study the proof also. Now let us consider the theorem BPT. The theorem is this. In a triangle, a line parallel to one side. A line parallel to one side. One side divides the other two sides in the same ratio. That is, in triangle ABC, if PQ parallel to BC, then AP by PB equal to AQ by QC. That is, AP is to PB equal to AQ is to QC. That is, AP is to PB equal to AQ is to QC. AQ is to QC. AP by PB. This is what is basic proportionality theorem. The theorem states like this. A line is drawn parallel to one side. A line is drawn parallel to one side in a triangle to intersect the other two sides. To intersect the other two sides. Then the line divides the other two sides in the same ratio. In a triangle, a line is drawn parallel to one side to intersect the other two sides. Then the line divides the other two sides in the same ratio. How can we prove this? To prove the result, consider this triangle. Triangle ABC. Line drawn parallel to PQ. We want to show that the condition is this. If PQ parallel to BC, then AQ is to AP is to PB. AQ is to PB is equal to AQ is to QC. This is what we want to prove. If PQ parallel to BC, then prove that AP is to PB equal to AQ is to AP is to PB equal to AQ is to QC. Now, for proving, join BQ and then draw the altitude from Q to altitude. Let the length of the altitude H1. Then join PC. and draw the altitude to AQ. This H2. Here we have, first consider two triangles. Triangle APQ. Another portion PBCD, CQ. Now, by drawing these lines, we divide this PBCQ into two triangles. Triangle PQB. Triangle PQB, consider. And a triangle CPQ. Two triangles. And triangle APQ. Consider these three triangles here. Triangle APQ, triangle PQB, and triangle CPQ. What is the area of AQP? Area of AQP. This triangle. Base into half BH, half base into altitude, base AP, half into AP into altitude H1, half base into altitude APQ H1. What is the area of triangle PQC? What is the nature of triangle PQC? PQB, what is the nature of triangle PQB? Area of triangle PQB. PQB. What is the nature of which type of triangle is triangle PQB? It is an obtuse triangle. So, its altitude will be outside. In an obtuse triangle, the altitude. Which is the altitude of triangle PQB? Same, this H1. Line the whose height measure is H1. So area of triangle PQB equal to half into base PB into H1. What is the ratio of the areas? Area of AQB by area of PQB, triangle PQB is equal to half AP. Half cancelled. H1 cancelled. AP by PB. Now consider second type. That is same triangle. First we considered APQ. Now we can consider AQP. First we considered AQP. Now we can consider APQ. Consider triangle APQ and a triangle PQC or CQ. PQC triangle. So area of APQ equal to half AP. APQ. What is the base? AQ. Half AQ into H2. Half AQ into H2. What is the area of triangle PQC? It is also an obtuse triangle. So its altitude is outside. That is H2. Area of PQC. Triangle PQC is equal to half QC, basic QC, half into base into altitude. Now take the ratios. Half cancelled, H2 cancelled. So ratio of area of AQP by PBQ, AQP, this triangle by PQB. This and this triangle. The first triangle and this triangle. Area. Comparing the areas. Ratios of the areas. This first triangle and this. And what is AP by PB? AP by PB. What is the ratio of areas of the second triangle? Which is the second triangle? Second triangle is this triangle. This whole. This triangle and the previous one. So APQ area, the ratio of areas of APQ and PQC equal to AQ by QC. Now what is the relation between the area of AQP and APQ? APQ and AQP, they are same. That means these two are equal. Area of AQP and area of APQ are equal. That means numerators are equal. Then what about the denominators? Area of PBQ, this triangle and this triangle, this triangle and this triangle. Are their areas equal? Are the areas of this equal? Yes or no? Yes. Why? How can we say that the areas of these two triangles are equal? Remember the result. Given what is given? PQ parallel to BC. PQ is parallel to BC. Then these are the two triangles have the same base. Which is the same base? PQ. And stand between the same pair of parallel lines. These two triangles have the same base and between the same parallels. Base PQ and parallels BC. PQ parallel to BC. So their areas are equal. We have already learned it. If two triangles have the same base and between the same parallels have the same area. That is a property of triangles standing between the same parallel. That means area of PQB is equal to area of PQC. Therefore, numerators are equal, denominators are equal. What does it mean? AP by PB equal to, here also numerators are equal, denominators are equal, so ratios are equal. Therefore, AP by PB equal to, AP is to PB, or say AP by PB equal to AQ by QC. Implies AP is to PB equal to AQ is to QC. Because numerators are equal, denominators are equal. Area of APQ, because area of AQP equal to area of APQ, area of the same triangles, same triangle, area of PQB equal to area of PQC, areas of triangles with the same base and standing between the same parallel. So their areas are equal. Thus, we get AP by PB equal to AQ by QC. This is what is basic proportionality theorem. Basic proportionality theorem 6.2. Now, theorem, basic proportionality theorem. Think of the converse of BPT. What is BPT? In a triangle, if PQ parallel to BC, then AP is to PB equal to AQ is to QC. What can be its converse? With the theorem BPT is this: if PQ parallel to BC, then AP is to PB. AP is to PB equal to AQ is to QC. Then the converse can be, if AP is to PB equal to AQ is to QC, then PQ parallel to BC. That means in a triangle, that is converse of BPT, theorem 6.2. In a triangle, if a line divides two sides in the same ratio, then it will be parallel to the third side. It will be parallel to the third side. That is, in a triangle, a line divides two sides in the ratio, in the same ratio. Two sides in the same ratio. That is, if AP is to PB equal to AQ is to QC, then PQ will be parallel to BC. Then the line is parallel to BC. How can we argue this? Suppose PQ in this figure, consider ABC, and PQ is drawn in such a way that AP by PB equal to AQ by QC. The line is drawn in such a way. Now, what do we want to prove? To prove the converse, We want to prove that PQ is parallel to BC. PQ is parallel to BC. Right? Now suppose PQ is not parallel to BC. Then let us draw a line like PQ dash. Suppose PQ dash is parallel to BC. Given that PQ is the given line. Suppose it is not parallel to BC. Given that, given in the figure we are given AP is to PB equal to AQ is to QC. And then we want to prove that PQ is parallel to BC. If PQ is parallel to BC, suppose, then what will be? AP is to PB equal to AQ is to QC. Because of that, and if PQ parallel to BC, then the result is true. If suppose PQ is not parallel to BC, but AP by PB equal to AQ by QC, and suppose that PQ is not parallel to BC. Draw a line PQ dash parallel to BC. And now apply the theorem. What is the BPT? BPT means if PQ dash parallel to BC, then AP by PB equal to what? AQ dash by Q dash C by BPT. Now compare the right hand sides. AP by PB equal to AQ by QC. AP by PB equal to AQ dash by Q dash C. What do you understand from this? LHS are equal, so the RHS are also equal. That is AQ by QC equal to AQ dash by Q dash C. How can we establish that these are equal? And these are equal means if AQ by QC equal to AQ by QC equal to AQ dash by Q dash C means Q and Q dash are the same points. These 2 points will be same. How can we show that these are same? Or Q coincides with the Q dash. This is the only possibility. Q coincides with the Q dash or Q dash coincides with the Q. How can we prove this? To show that, add 1 on both sides. We get AQ by QC plus 1 equal to AQ dash by Q dash C plus 1. By simplification we get AQ plus QC by QC equal to AQ dash plus Q dash C by Q dash C. What is AQ plus QC? AP by QC. AQ by QC. AQ by, what is AQ by QC? AC. AQ plus QC, sorry. AQ plus QC equal to AC. This is AC by QC equal to, what is AQ dash plus AQ dash plus Q dash C? AC. Denominator Q dash C. Now look, numerators AC equal to AC. Then denominators QC and Q dash C are equal. What do we get from this? Q and Q dash are same point. Q and Q dash represent the same point. That means PQ and PQ dash are the coinciding lines, same line. That means PQ is parallel to BC. So the converse of BPT is this. In a triangle, a line divides two sides in the same ratio will be parallel to the third side. Now, read textbook pages 123 to 126. Do the examples 1, 2 and 3. Also, do exercise questions 6.2, all the questions. Thank you.